Ideal gas law. Ideal gas law. It is a hypothetical gas. Intermolecular forces do not exist to complicate. Ideal gases are essentially point masses moving in constant, random, straight-line motion. Its behavior is described by the assumptions listed in the kinetic molecular theory of gases. The ideal gas law is simply the combination of all simple gas laws. 1. Boyle's law describes the inverse proportional relationship between pressure and volume at a constant temperature and a fixed amount of gas. P is inversely proportional to V, or P1V1 equals P2V2. 2. Charles's law describes the directly proportional relationship between the volume and temperature, in Kelvin, of a fixed amount of gas, when the pressure is held constant. V is directly proportional to T, or V1 over T1 equals V2 over T2. 3. Avogadro's law, volume of a gas is directly proportional to the amount of gas at a constant temperature and pressure. V is directly proportional to N, or V1N1 equals V2N2. 4. Gay-Lussac's law, given a constant number of mole of a gas and an unchanged volume, pressure is directly proportional to temperature. These laws are also known variously as the pressure law or Montan's law and Dalton's law respectively. P is directly proportional to T, or P1T1 equals P2T2. Four gas variables. Pressure, P. Volume, V. Number of mole of gas, N. Temperature, T. The formula of ideal gas law, PV, equals nRT, where P equals pressure, atm, V equals volume, liters L, N equals number of moles, mole, R equals the ideal gas constant, 0.08206 liter atm over mole Kelvin. T equals temperature, Kelvin. Standard temperature and pressure, STP. P equals 1 atm. V equals 22.4 liters. N equals 1 mole. T equals 273 Kelvin. Some applications of ideal gas law. How do balloons fly? The balloon will be filled with a hot gas molecules in a constant pressure and temperature. Therefore, the volume of the balloon increase, and by adding more particles, the balloon will be completely filled with hot gas particles. The hot air contains less number of molecules than in the same volume of a cool air. As a result, the hot gas is less dense than the air in the atmosphere, causing the balloon to rise up in the air and fly. Diesel engine theoretical efficiency. The efficiency of the diesel engine can be derived from the constant pressure and volume, since the compression of air is adiabatic, which means that it happens without the gain or loss of heat. The energies that are put into and out related to the efficiency are calculated from the temperatures and heat. In order to display this efficiency, it is expressed using the ideal gas law PV equals nRT in terms of temperature and heats. This law is also used to avoid explosions and fuel combustion. Football. For instance, if a football team plays on a cold day where the temperature is low, the volume of the football would be decreased. As a result, one might need to add more molecules into the football to equalize with the volume on a normal day while having the same mass. Let's try to answer the following. Standard conditions for temperature and pressure are standard sets of conditions for experimental measurements. If the value of standard pressure is 1 atm, what is the value of standard temperature? D. 273 Kelvin. Ideal gas law is a hypothetical gas whose molecules occupy negligible space and have no interactions, and which consequently obeys the gas laws exactly. In this law, which variable represents the gas constant? V. R. Which of the following variables is not included in the ideal gas equation? A. Mass. The equation PV equals nRT shows the relationship between a variety of gas properties. What is this equation called? C. Ideal gas law. Each of these flasks contains the same number of molecules. In which container is the pressure highest? A. Flask 1.